This problem, it says a cylindrical hoop of mass of 3 kilograms and radius of 0.2 meters has a rope around it with one end tied to the ceiling. The hoop is dropped and falls while the rope unwinds and spins the hoop. After the hoop drops 2 meters, what is the downward velocity of the center of mass? So we know that relative to our position 0, 2 meters above it, the hoop has potential energy called mgh. And when it falls, it turns the potential energy into kinetic and rotational energy. So for this we can use conservation of energy. mgh is equal to 1/2 mv squared plus 1/2 iw squared. We need to turn I and w into things that we can plug in from the equation given. So we know that I of a cylindrical hoop is just mr squared, so we can plug it in there, and w is v over r. Then we shove in all the constants that we know. mgh, 3 is the m, h is 2, g 9.8, 1/2 m of 3 times v squared, which is what we're trying to find, and 1/2 mr squared times w squared. And if we keep going, 58.8 is equal to 1.5 v squared, it's 3 over 2, plus 1/2 m, which is 3, times r squared, turns into 0.4, over v squared over r squared, which is 0.4. And the 0.4's happen to cancel out, and we're left with 58.8 is equal to 1.5 v squared plus 1.5 v squared. If we take the v squared out of the equation and make it its own thing, we can divide the 1.5 plus 1.5, which turns into a 3. So 58.8 over 3 is equal to v squared, and if we go with that equation, then v is equal to 4.427 meters per second.